If f is a quadratic function such that f of 1 equals negative 1, f of 4 equals 5, and f negative 1 equals 15, find the y-intercept of the function. So first we need to find what the function is. So the function, the general form, is going to be y equals ax squared plus bx plus c. So we need to figure out what is a, b, and c. Now with the function notation that is given to us, we have 3 points that we know to be true. We know we have the points 1, negative 1, we have 4, 5, we also have negative 1 and 15. So looking at the first point, we can plug 1 in for x and negative 1 in for y with the general equation that we have written. So we get negative 1 equals a times 1 squared plus b times 1 plus c. So negative 1 would equal a plus b plus c. We now do the same thing with the second point, 4, 5, where we plug a 4 in for x and a 5 in for y into that general equation. So we get 5 equals a times 4 squared, which is going to give me 16a, plus b times 4, which is going to give me 4b, plus c. The third one, negative 1, 15, will give me 15 equals a times negative 1 squared, which is 1, so I have 1a, plus b times negative 1, which is going to give me a negative b, and then plus c. So I have 3 equations here that I need to use to find a, b, and c, so I can find my equation, and so that ultimately I can find the y-intercept of that function. So if I look at the first 2 equations that I have created right here, and I try to solve for one of the variables, c would be an easy one to solve for, and if I subtract the 2 equations, the c's will cancel out. I'm left with an a and b. So when I subtract these, I'm going to get negative 6 equals negative 15a minus 3b, and then the c's will cancel. If I then take a look at the first and the third equations that I have, the negative 1, 1, and then also the 15, 1, and then if I were to add these together or subtract these to get things to cancel, and actually I probably want to subtract because the a's and the c's will both cancel when I subtract those two, then I'm left with just one variable left over. So let's subtract these 2 equations, where now I have negative 1 minus 15, so I'm going to get a negative 16 equals a minus a will cancel, I'm left with nothing. B minus negative b will give me a 2b, and then the c minus c will give me nothing. So here, now I have an equation where I can solve for b, and so I'm going to get b equals negative 8. So b equals negative 8, I can now plug that into the second equation I have here and solve for a. So when I do that, I'm going to get negative 6 equals negative 15a minus 3 times negative 8, which is going to give me a plus 24. So when I solve this for a, I'm going to get negative 15a is equal to negative 30. So a is going to equal a 2. So now I have b equaling negative 8 and a equaling 2. And now I can plug both of these into any of my original equations and solve for c. So I'm going to choose that first equation to plug it into, where it says a plus b plus c equals negative 1. So if a is 2, b is negative 8, we're trying to find c, and that's all equal to negative 1. I can now solve for c, where I get c would equal 5. So now I have a is 2, b is negative 8, c is equal to 5. So now I can put this into my original equation, my general form, where I have y would equal a, which is 2, x squared, plus b, which is negative 8, times x, plus c, which is 5. So this is my equation, my function, and I'm trying to find the y-intercept of the function. Now don't forget what y-intercept means. Y-intercept is where it crosses the y-axis, and anywhere it crosses the y-axis, x is going to be 0. So I plug a 0 in for x, and I'm going to get y would equal 2 times 0 is 0, minus 8 times 0 is 0, plus 5. So y is going to equal 5. So my answer, the y-intercept of this function, will be y equals 5.